Hey everyone, let's take a look at this interesting geometry problem together. We're given a square with a side length of 10. We need to find the area of the shaded region, which is obviously an irregular shape. Since we can't directly calculate this, we'll have to obtain the result by adding or subtracting the areas of two or more regular shapes. If you want to give it a try yourself, pause the video now. I will begin in 3 seconds. In fact, if you observe closely, you'll notice that this square is made up of 4 irregular shapes with equal areas along with the shaded region. To find the area of the shaded region, we can subtract the areas of 4 squares from the area of the square. To make it easier for you to see and understand, I will break down this square into 5 parts, including the shaded region and the 4 irregular shapes with equal areas. To distinguish them clearly, I've colored these 4 irregular shapes differently. In Figure 1, once we determine the area of the yellow part, it will be easy to calculate the area of the shaded region. What should we do? Firstly, connect AB and BD. Since both AB and BD are radii of the circle, triangle ABD is an equilateral triangle. For a clearer view, let's isolate this part. In Figure 3, let's designate the area of the yellow irregular shape as S1, the area of the arc as S2, and the area of equilateral triangle DBA as S3. Since all angles of an equilateral triangle are 60 degrees, angle BAD is also 60 degrees. Therefore, angle CAB is 90 degrees minus 60 degrees, which equals 30 degrees. In sector ABD, S2 equals the sector's area minus S3, where the area of an equilateral triangle is calculated using the formula 4 divided by the square root of 3 times the square of the side length. S3 is equal to 4 divided by the square root of 3 times 10 squared. S3 equals square root of 3 over 4 times 10 squared, which simplifies to 25 times square root of 3. The area of sector ABD is calculated as 60 degrees over 360 degrees times pi times 10 squared, which simplifies to pi over 6 times 100, equaling 50 pi over 3. S2 equals 50 over 3 times pi minus 25 times square root of 3. The area of sector ABC is calculated as 30 degrees over 360 degrees times pi times 10 squared, which simplifies to 1 over 12 times pi times 100, equaling 25 over 3 times pi. S1 is calculated as the area of triangle ABC minus S2, which simplifies to 25 over 3 times pi minus 50 over 3 times pi minus 25 times square root of 3, resulting in 25 times square root of 3 minus 25 over 3 times pi. The shaded area, S, is computed as the area of quadrilateral FDAC minus 4 times S1, which simplifies to 100 minus 4 times 25 times square root of 3 minus 25 over 3 times pi, resulting in 100 minus 100 times square root of 3 plus 100 over 3 times pi. Equals 100 multiplied by 1 minus square root of 3 plus pi over 3. I hope this video brought you some fun. See you in the next one.